Hi there. Let's go over the topic 3 review. So let's do the vocab first. Resistance would be defined as the measure of how difficult it is for the electrons to flow through a substance, and its unit is always in ohms. Tungsten is a type of metal used in certain wires. Tungsten has a high resistance, so if you have a tungsten wire, that means the metal helps slow down electrons. And so tungsten wires are often used in old incandescent light bulbs. So inside here we have a bit of a vacuum, and then the tungsten wire creates enough resistance, therefore friction, heat, and then light. So that's what tungsten is. Ohm is a unit of resistance. Ohm's law states that as long as the temperature stays the same, the resistance of a conductor will stay constant, and the current is directly proportional to the voltage. So that means R resistance is voltage divided by current, or I, which is current, is equal to voltage divided by resistance, or V voltage is equal to I current times R resistance. So 3 possible versions of Ohm's law. A series circuit is a circuit in which there's only one single path for the current to travel, and a parallel circuit is a circuit in which the current can flow in many different paths. Number 2, in your own words, explain the meaning of resistance. Resistance makes it difficult for the electrons to flow, so something with a high resistance means that it's blocking or slowing down the flow of electrons. So for example, if we had a river and the water flowing down the river was representing the electrons, if we put big rocks and boulders into the river, that's going to slow the flow down. So the rocks and the boulders would be R, the resistance, and the flow of water would be the current, how fast it's going. I'll explain the difference between current, voltage, and resistance. Well, current is the movement of electrons, basically the rate of flow. Resistance is what slows down the flow, and voltage is what makes the electrons go, how fast, how much pressure we can push them. So back to our water analogy, let's say we had a waterfall that was this steep, and the water came down the waterfall like that. And let's say we had another waterfall that was about that steep, and the water came down the fall like that. Which of these two, A or B, would have faster moving water? A. Why? Because it's got a higher way to fall. So which would have higher voltage? A would have higher voltage, B would have lower voltage. State Ohm's law. Well, we've done that already. Resistance is the voltage divided by current. Remember, we can move these around. We could also say that voltage equals resistance times current. And there are lots of examples of practice problems using this formula. What are the major uses of resistors? Resistors are used to control current or voltage to suit certain needs. Variable resistors have the resistance change in response to temperature or light, voltage, or some other variable. Common uses are light dimmer switches, motor speed controls, surge protectors, refrigerator and stove temperature controls. What's the difference between a parallel and a series circuit? Let me show you that right here. So here's a picture of a series circuit. In series, the electrons only have one way that they can go. So if you have resistors in there, everything gets backed up. In other words, the more resistors you add, everybody has one path, so it's like a one-way highway. So it really starts to slow down the flow of electrons, or in the case of a highway, the traffic. Whereas if the electrons have different pathways and you have different resistors in here, then the electrons can take different paths and the amount of resistors doesn't slow the flow down as much. So parallel circuit, there are several branches. Let's keep going. Number 6, what type of circuit is used in household wiring? Household wiring uses parallel circuits. It uses more wire, but you can turn off or on lights and appliances separately, as the fact that the brightness of the house does not depend on the number of lights. And number 7, other than the type of material used, list 3 other factors that affect resistance and explain how resistance might be changed or altered. Well, here are the factors that we can use to control resistance and therefore the flow of electrons. The length of the wire. So the shorter the wire, the faster the electrons can flow and the higher the resistance. Let me go to this page to show you. So resistance increases with length. So if the length doubles, the resistance doubles. So the shorter the wire, the faster they flow. The cross-section resistance decreases with area. So if the cross-section area doubles, the resistance is halved. So that has to do with the thickness of the wire. Okay, they use wire gauge numbers, AWG. Thicker wires have larger cross-section and they have lower resistance. So the bigger the wire, the thicker it is, the more lanes basically that the electrons can flow down and the faster they flow, like a traffic. Do you have a tiny 1-lane highway or do you have like a big huge 5-lane highway? The 5-lane highway would allow traffic to flow faster, less resistance than the 1-lane highway. Temperature affects resistance. As the temperature of the wire increases, so does the resistance. So cooler or colder wires allow electrons to flow a lot faster. Warmer wires cause electrons to slow down more, and there's more resistance. And the material, due to the structure of atoms, some metals allow electrons to flow more freely. For example, gold and copper are good at conducting and they have low resistance. However, something like tungsten and nichrome are wires that tend to allow more resistance or slow the flow of electrons down more. So temperature, cross-section, length of wire, and type of wire. So that helps you explain some of the concepts in topic 3.